Hi, I'm Miss Hearn. Let's get started. In this video, we're going to find the limit as x goes to 0 of 2x times cosine of 9x minus 1 over sine of 5x minus 5x using L'Hopital's rule. Let's just review what L'Hopital's rule actually tells us. Basically, if you want to take the limit as x approaches 0, just going to use 0 for the example here. You can actually apply L'Hopital's rule as x approaches any value. If we have the limit as x goes to 0 of a function f of x over a function g of x, and we find that if we plug in 0 to f, that we get 0, and when we plug in 0 to g, we get 0. This gives us the indeterminate form 0 over 0. And by L'Hopital's rule, we know that instead of evaluating that limit, we can find the limit as x goes to 0 of the derivative of f over the derivative of g. That will be equivalent to the original limit that we were looking for. Now, if when you do this, you find that you try to evaluate the limit by plugging in 0 and you get f prime of 0 is 0 and g prime of 0 is also 0, then again you have the same situation. So you can repeat the process and take the derivative again of each part. So the limit would be equal to the limit of f double prime of x over g double prime of x. And should those both turn out to be 0 when you plug in, then you could actually repeat that process again and do the third derivative and so on. So in our problem, thinking of the 2x times the quantity cosine of 9x minus 1 as our f of x and the sine of 5x minus 5x as our g of x, we know from the instructions that we're going to end up having to apply L'Hopital's rule. So what that means is if we check by plugging the 0 in for x, we should see that f of 0 is 0 and so is g of 0. Let's check. F of 0, let's see, we're going to have 2 times 0, and then that's going to be multiplied by the whole quantity in parentheses. So no matter what's in those parentheses, 0 times that is going to be 0. And g of 0, sine of 0 is going to be 0 minus 5 times 0 would also be 0. So g of 0 is 0 minus 0. So that's 0 as well. So we're going to find the first derivative of each part, the numerator separately from the denominator. By the way, a lot of times people, when they're first applying L'Hopital's rule, they think they have to do a quotient rule, and that's not correct. L'Hopital's rule said you just take the derivative of the top over the derivative of the bottom. This is not the same as taking the derivative of the whole quotient. So the derivative of the top is going to require the product rule because we have something with an x being multiplied by a quantity with an x. So we're going to take the first part, 2x, times the derivative with respect to x of the second part, cosine of 9x minus 1, plus the second part, which is cosine of 9x minus 1, times the derivative of the first part, which is 2x. So that's going to be equal to 2x times the derivative of cosine of 9x requires the chain rule. The derivative of a cosine is negative sine, but since we have something other than x here, it's going to be the negative sine of 9x times the derivative of 9x, which is 9. So this is actually going to be negative 9 sine of 9x. Plus, we have cosine of 9x minus 1 times the derivative of 2x is just 2. Simplifying a little bit, this is going to be negative 18x sine 9x plus 2 cosine 9x minus 2. And remember, what we're interested in here is if we plug 0 into that, what will we get? So let's go ahead and find f prime of 0. This first term is definitely going to be 0. You have 0 times the sine of 0 is 0. Plus, we're going to have 2 times 1, which is 2, minus, because cosine of 0 is 1, so 2 times 1 is 2, minus 2, so this is going to turn out to be 0. Now, that doesn't necessarily mean we're going to need to continue with L'Hopital's rule. It depends on what happens with the derivative of g. So to take the derivative of g, we do not need a product rule. We do need a chain rule though. Sine of 5x Derivative of sine is cosine, positive. The derivative of 5x is 5. So we have g prime of x equals 5 times the cosine of 5x. Now the derivative of negative 5x is just negative 5. So let's see what happens when we plug 0 into g prime. We're going to get 5 times 1, which is 5, minus 5 is 0. So once again, we see that we have a 0 over 0 indeterminate form. So we're going to have to find the second derivatives. We're taking the derivative of f prime, which was negative 18x sine of 9x plus 2 times cosine 9x minus 2. All right, so that first term is a product. It's going to require the product rule, something with an x times something with an x. So for the first term, when we find our second derivative, we have to have the first function, which is negative 18x, times the derivative of the second function, which is the derivative of the sine of 9x, plus the second function, which is sine of 9x, times the derivative of the first, the derivative of negative 18x, plus we have to have the derivative of 2 cosine 9x. That requires the chain rule, so we're going to have, by the way, the derivative of cosine is negative sine, so this is going to turn negative. So this is going to be minus, and we're going to have 2 times sine of 9x times 9, and then the derivative of negative 2 is just 0. So second derivative of f will be negative 18x, derivative of sine of 9x by the chain rule would be 9 cosine 9x plus sine of 9x times, and the derivative of negative 18x is just negative 18. And then we have minus 18 sine of 9x. If we multiply that 2 times the 9, we can simplify a little bit more. So negative 18 times 9 is negative 162x cosine of 9x minus 18 sine 9x minus 18 sine 9x. And those two are like terms, so we actually have negative 162x cosine of 9x minus 36 sine 9x. So that's our second derivative. We're going to need to plug 0 into it to evaluate our limit. So let's see what that would be. That's going to give us a 0 in the first term, since 0 times anything would be 0. And then it's also going to give us a 0 in the second term, because sine of 0 is 0. So 0 minus 0 is going to be 0 again. Let's find the second derivative of g. Remember, the first derivative of g was 5 cosine 5x minus 5. So we're taking the second derivative now. So g double prime of x is going to be derivative of 5 cosine 5x. We're going to have a negative 5 sine of 5x times 5. Derivative of negative 5 is just 0. So the second derivative of g is going to be negative 25 sine 5x. Now, if you plug 0 into that, you're going to get sine of 0 is 0. So once again, we've now rewritten using LHopitals' rule. We've worked our way from the original to the first derivative over the first derivative to the second derivative over the second derivative, but each time we get the indeterminate form 0 over 0, which tells us we can apply LHopitals' rule again. So now we're going to have to find the third derivative. Remember, our second derivative of f turned out to be this guy here, negative 162x cosine 9x minus 36 sine 9x. When we find the third derivative, we're going to have a product rule again. We have negative 162x is our first part of that product, times the derivative of the second part, cosine 9x, plus the second part, cosine 9x, times the derivative of the first. Okay, but then we still have to take the derivative of the second term, negative 36 sine 9x. So that's just going to be negative 36 times the derivative of the sine is a positive cosine, but it's a chain rule because there's a 9x in the argument, so that's going to be times 9 cosine 9x. Our third derivative of f is going to be negative 162x times derivative of cosine 9x is going to be negative 9 sine 9x by the chain rule, plus cosine of 9x times derivative of negative 162x is just negative 162. Let's see, negative 36 times 9 is going to be negative 324 cosine of 9x. Simplifying a little bit here, we have f triple prime of x is equal to 1458x sine 9x. And then we're going to have minus 162 cosine 9x minus 324 cosine 9x. Those are like terms. Let's combine them. So our third derivative will be 1458x sine 9x minus 162 and 324 comes to 486 cosine of 9x. So let's see what our third derivative evaluated at 0 would be. So this first term's definitely going to be 0 minus, now cosine of 0 is 1, so minus 486. So it's going to be negative 486. So we know right away we're not going to be applying L'Hopital's rule a third time. So let's see what happens with g. And remember, our second derivative was negative 25 sine of 5x. So our third derivative, we're going to have negative 25 times, the derivative of sine is cosine, but it's going to be 5 cosine 5x. So that means that the third derivative is negative 125, 25 times 5 is 125 cosine of 5x. Evaluating that at 0, we are going to have negative 125 times, and then this will be 1, cosine of 0 is 1. So our original limit was the limit as x goes to 0 of our original f of x over g of x. We've worked it using L'Hopital's rules, applying it several times to the third derivative of f over the third derivative of g. And we've just figured out that when we plug in our third derivative at 0 turns out to be negative 486 over negative 125, or 486 over 125. The negatives cancel out. I hope you found this video helpful. If you did, please remember to give it a thumbs up. That helps other students to find the video.